Okay, welcome back to the next video. We are going to continue. We talk about including or first finding out what's the restriction of a graph. Next will be your intercepts, right? And then under your intercepts, you have your x-intercept and then you have your y-intercept. So far we could talk about these two. Next is your stationary points, right? Stationary points. This is very, very important to always include because most of the time for all graphs that you draw, you will not draw a simple straight line graph, right? It most likely will be a curve. So with curves, there will definitely be stationary points. And in the A-level context, a curve that you draw can have multiple stationary points, right? It's not like secondary school where they ask you to draw a quadratic, they ask you to draw a cubic, and the number of stationary points is more or less the same every single time. Okay, so my biggest tip for you for stationary points is to always just use GC to observe. Again, I'm going to show you an example right now. Okay, so let's say I use a curve of, for instance, y equals to x squared over x plus 5, right? Okay, how does this graph actually look like? So let's just use the GC over here to help us figure out. Okay, so let's say I clear this, and then here I clear this, and then I come back here, and then I put this, and I put x, I come back here, and then I come back here, and then I put x squared over x plus 5. Enter. Okay, so we see there's only one stationary point over here, right? But how do we actually calculate the coordinates of the stationary point? So this is where on your GC, you press second, calculate, and then, obviously here you can observe it's a minimum point, right? So you calculate, you go down to minimum, and then you just need to drag the cursor near to the turning point, right? So you don't need to exactly nail the turning point, but you just need to drag it near enough so that the GC knows which minimum point you're talking about. So let's say I just put here, left bound, okay? Once I sort of get it, I press enter, and then I'm gonna go to the right, and I press enter, and I press enter one more time. And then that is where the minimum point is being found, right? So over here, we can see that our minimum point is actually 0, 0. Now, these values over here, right, even though it's not 0, it's basically as good as 0 already. So we can just take it that it's 0. Because in the GC, if it's not exactly 0, they won't put 0. But it's so small to the point that you can assume it's 0, right? 9.8231 e negative 7 and y equals to 1.93 e negative 13. Right, so what does this actually mean when we write it out, right? E means 10 to the power of. So this is 9.8231 times 10 to the power of negative 7. This is 1.93 times 10 to the power of negative 13. And then if you count the number of zeros, right, it's as good as saying it's 0.00001, 2, 3, 4, 5, 6, 7, 8, 2, 3, 1, right? It's so small, and this one is even smaller, right? So for these two cases, it's as good as 0 already. So we will say that the minimum point for this curve would be 0, 0. Okay, very, very important to identify all your stationary points in a curve. And just note that stationary point includes your max, min, and point of inflection as well. Okay, point of inflection means go up, flat line go up, or go down, flat line go down, right? It's as simple as that. If not, that's it, and I hope that this demonstration of how to use your GC to find a stationary point was helpful. If not, I'll see you in the next video.